Bismillah ar-Rahman ar-Rahim. Alhamdulillah, salatu salam ala Rasulullah. Welcome back. Today we're gonna continue chapter 4. In this lecture, we will learn how to derive the equation how to derive the transfer function. How to derive the transfer function for this problem. This is a typical problem, very nice problem. What do we have here? We have a mass and 2 degrees of freedom, x and y. We have external force, P of t, 2 springs and 1 damper. There is a degree of freedom here between the K2 and B, the damper and K2. Okay, there is a degree of freedom, in fact, so that's why we have 2 degrees of freedom in this system. All right, what we're looking for? We're looking for the transfer function. Now, whenever you see a problem asking for the transfer function, he should say clearly what's the input and what's the output. So clearly from here, the input, he said P of t. How do I know this? Because it's the denominator of the transfer function, P of s. And the output is x of s, this one, the displacement of the mass. This is the input, this is the output, okay? Okay, so this is the input, and this is the output. This is the output, and this is the input. Okay, find the transfer function. This is what we're looking for. All right, so how are we going to do this? All right. We're going to start with the free body diagram. Just redraw the free body diagram or the mass. Start with the mass. Usually we show the degree of freedom x. Oops. We always have this problem. Okay. This one is x. Okay. And we have degree of freedom here. Stick to your model, just like your model, what he said. He said there is degree of freedom here. This one, there is degree of freedom here. Okay, and this one, the node, moving node. Okay, we have to be very patient using the pen. He said this one is y. Okay, all right. Now show the forces acting on each degree of freedom. So we will start with the mass. We have external force, P of t, downward. And we have 2 reaction force, one from the spring and one from the other spring. One from the other spring. Okay. Let me write it in a better way. Okay. Put it here so we can write down. Okay. How much this force? This force is very easy, this reaction force. K1 against what? Against x only. The other side is not moving. What about this one? This one you have to be careful because there are 2 degrees of freedom on this element. One from x and one from y. So if you start from x, you said this one is against x, right? So it's going to be K2 against x minus the other end, which is y. All right? And that's all. So this force here, K2 x minus y. And now from Newton's third law, okay, if you have one element and there is one force on one side, the other end will be the same force but opposite direction. Okay, opposite direction. I hope this is clear. If it's not clear, I will move it a little bit up so you can see it better. We have y here. This is y. So it's going to be here, downward. Okay. Now we're done with degree of freedom x. What about y? Almost done. We have one force here, downward, and it's K2 x minus. And the other end, we have a damper, always against the motion, and it's going to be b y dot. Okay. Again, let me write it below the line so you can see it clearly. No doubt we have here. So it's going to be b y dot. This force is b y dot. خلاص. This is your free body diagram. We're done. Okay. Now, how are we going to derive the transfer function? We need to derive the equation of motion. Now we have 2 degrees of freedom, so we start with degree of freedom x. Apply Newton's second law, summation of forces. Summation of forces equal mass times acceleration. Okay. Mass times acceleration. Okay. What is the positive direction of force? Downward. Okay. Now on the mass, we have what? We have P of t minus K1 x minus K2 x minus K2 x minus y, right? K1 x, K2 x minus y equal the mass times the acceleration of x, which is x double dot. And this is equation of motion number 1, and we will give it number 1. خلاص? Alright, now let's go to degree of freedom y on the other slide. Degree of freedom y. Degree of freedom y. Oops. Degree of freedom y. Apply Newton's second law. Summation of forces equal mass times acceleration. This is my positive direction of force. We have what? We have two forces only. We have negative by dot and positive k2. So it's going to be a positive k2 x minus y minus by dot equal the mass. We don't have a mass here, right? It's only a point, moving point. So it's going to be 0. This one is very easy. And this is the equation of motion at degree of freedom y, and I'm going to call it number 2. خلاص? All right. Now we have how we going to find the transfer function? Just like we did last time, just like we learned last time, you need to apply or take the Laplace transform for all the equations of motion, assuming 0 initial conditions. Take the Laplace transform, assuming 0 initial conditions. This is the only way, okay, to derive the transfer function. So apply Laplace transform for 1, from 1, the first equation of motion, this one. Apply Laplace transform and assuming 0 initial conditions. So from 1, again, let me, okay. P of t, I'm going to call it P of s. I don't know what's this equation, I don't care. Just let's call it P of s. Minus K1x, K1 xs minus K2 x minus y, K2 xs minus y of, okay. X minus p, oh, not b. Oops. What happened? Don't know why I erased everything. Let me keep this again. Redo. Okay. Nothing. Okay, no problem. Let's do it again. Let's do it again. Where are we? Ah, let me do a degree of freedom y again, okay? No problem. We have to be very patient with this online teaching. Okay, degree of freedom y. Apply Newton's second law. Summation of forces equal mass times acceleration. This is my positive direction force. It's going to be K2 xs minus y of s minus b of s ys equal to, is it ys? Yes. Equal to 0. This is equation number 2. Okay? Equation number 2. Now, how are we going to derive the transfer function? Take the Laplace transform of the equations of motions, assuming 0 initial conditions. So from 1, we will have P of s minus what, K1 xs minus K2 xs minus ys equal to ms square xs, right? Yes. And let's call this equation number 3. Now from 2, this one, take the Laplace transform. It's going to be K2 xs minus ys minus, oops, what did we do? Okay. Sorry about that. This is not the equation of motion. I know you noticed this. Sorry about this. We took the Laplace transform directly because we continued from the last step. Let me redo it again. Sorry about this. Okay, no problem. Let me write the equation of motion again. Okay, I jumped to this step. Sorry about this. So what do we have here? We have K2 x minus y minus by dot equal to 0. So this is going to be minus K2, yes, minus bs ys equal to 0. Okay, this is equation number 4. All right, last step, what we're going to do, we have two algebraic equations. Okay, be careful here, ya shabab, how to derive the transfer function for any problem. We have two algebraic equations. Okay, after Laplace transform, we have two algebraic equations. How many variables or functions we have? We have 3. P of s, x of s, y of s. These are the only 3 functions. So we have 3 functions and 2 equations. Can we derive the transfer function? We're looking for what? We're looking for the transfer function that we're looking for. Let me remind you. X the output and P of s the input. Okay. Let me write it again. Erase this. Okay. So how are we going to derive? We need to eliminate what? We need to eliminate y of s. Okay. This is what we don't want to see. Okay, y of s. Okay. So how are we going to do this? We solve for y of s from equation number 4 and substitute in 3 and you will be done. The transfer function will be done. So let me recall 4. Okay. So from 4, collect all the coefficients of x together on one side. So we have what? K2x on one side. From 4, K2x on one side. And on the other side, bs plus K2. bs plus K2 times what? Times y of s. Solve for y of s. It's going to be K2 xs over bs plus K2. This is equation number 5, right? Last one is 4, this one is 5. All you have to do, substitute 5 in which one? 3. Why we substitute 5 in 3? In order to eliminate y of s. So substitute 5 in 3. So in 3 we have P of s K1 xs. P of s. Okay. P of s minus or plus P of s minus K1 xs minus K1 xs. Okay. Minus K1 xs. P of s K1 xs K2 xs minus ys. Sorry, we need to substitute y of s. Okay, what is y of s? It is K2, this one, huh? K2 xs over bs plus K2. Okay, then equal to ms square. Equal to ms square xs. خلاص, you need to simplify this equation. Collect all the coefficients of p together on one side, all the coefficients of x on the other side, and then the transfer function will be ready. Okay? Will be ready, inshallah. Let me do this one step here. It's easy. P of s equal to K1 plus K2 plus K2 plus or minus plus K2 squared over bs plus K2 plus the last one, which is ms square, all multiplied by x of s. So let's go to the last step, the transfer function. We're looking for is what? X of s over p of s. It's going to be 1 over what? This one, ms square. sorry, m s square plus what? K1 plus K2 minus K2 square over Bs plus K2, right? After arranging ms square, K1 K2, K2 squared over Bs مظبوط. Okay. All right. Now this is the transfer function, but we are halfway يا شباب. If you stop here, you will lose half the points. Why? Because we need to rearrange, organize the transfer function. I mean, you have to put the transfer function the same way you put it in MATLAB. You need to see a polynomial in the denominator in order. And also you need to see a polynomial in the numerator in order as well. So what you're going to do with this one, you need to simplify. How are you going to simplify this? You multiply by bs plus k2, numerator and denominator, both of them. So this one will be bs, bs plus k2 plus k2. Then this is going to be ms square plus k1 plus k2 multiply by bs plus k2 minus k2 squared. Okay, need to simplify, multiply and distribute the terms. So what do we have here? We have here bs plus k2 the top, and this one will be mbs cubed, okay. Then we have mbs cubed and k2 plus k2 or mk2, this one multiplied by k2, right? mk2 s squared, okay, plus k1 k2 bs, right? Plus k2 squared, or we did this before, no, the last one, this one, k1 plus k1 k2, this one multiplied by k1 plus k2, so it's going to be plus k2 squared, and we have here negative k2 squared, so clearly those two will cancel with each other and you're left with this transfer function. Let me write it on the last page. The transfer function that we got after rearranging the output x of s, the input p of s, okay, we have in the top b, okay, we have in the top we have here bs plus k2, and here we have mbs cubed plus mk2 s squared, k2 s squared plus k1 k2 bs plus what? K1 plus K2 B, K1 plus K2 Vs plus what? The last term, K1 plus K2. Oops. Plus K2, 1, 2, 3, 4. Let me write it clear here so we can compare to the last. Bs equal to Bs plus K2 Bs cubed plus mk2 s squared plus k1 plus k2 bs plus k1 k2. This is your transfer function. Okay, I hope it's clear. Okay, let me check if it's correct or not. I hope it's correct. bs k2, bs plus k2, bs plus k2, what is it? Correct. mbs cubed, mbs cubed, mk2 s square, mk2 s square, plus k1 plus k2 bs plus k1 plus k2 bs, right? Yes, مظبوط. And k1, this one k1 يا شباب, this is a typo error, it's a typo. This one should be how much? This should be, oops, k1, this one k1 k2, okay, k1 k2, k1 k2, okay, it's the same, so it's correct. You need to practice this problem يا شباب. This is the least you have to do, okay, before the test, the quiz or the midterm, and also in addition to your homework, and you will be inshallah ready. All right, thank you very much.